Hello, welcome back to the online course on analog integrated circuits. Today we are going to start with fifth module. In the fifth module, the first topic is IC555 and its applications. Most important applications of IC555 are stable and monostable multivibrator. Here we can see some of the previous year questions from KTO B.Tech examination. The first three questions belong to the monostable multivibrator topic, and the fourth question belong to both monostable and stable multivibrator. The last question is a design problem. Before answering all these questions, let's look at what IC555 is. 555 is an important IC which is useful in timer, pulse generation and oscillator applications. In this course we are going to study the most important two applications, that is monostable multivibrator, which comes under pulse generation application, and a stable multivibrator, which comes under oscillator application. Here we can see the pinout diagram of IC555. There are 8 pins available in IC555, each having some specific functions. They are ground, trigger, output, reset, control voltage, threshold, discharge, power supply. Here is the internal circuit diagram of IC555. Inside the IC we have several components. It has 3 resistors, 2 comparators, RS flip-flop, a buffer and 2 BJT switches. Let us look at the connections. This is the ground and we have VCC here. These comparators won't draw any current through this link. Then we have these resistors are in series. These resistors have same resistance value, which is 5K. Hence the value of voltage across each resistance will be equal, that is VCC by 3. The voltage across this point will be VCC by 3 because we have a single resistance in between this point and ground. Also, the voltage across this point is 2 VCC by 3, as we have 2 resistors in between this point and ground. These voltages are applied to the comparators for comparing those voltages with threshold voltage and trigger input voltage. Let us look at the first comparator. We have 2 VCC by 3 is applied across the inverting terminal and the threshold input is applied across the non-inverting terminal. Then whenever the threshold is higher than 2 VCC by 3, the first comparator will produce a high output. Whenever the threshold is less than 2 VCC by 3, then it will produce a low output. In the case of comparator 2, the 1 by 3 VCC voltage is applied across the non-inverting terminal and the trigger input is applied across the inverting terminal. So when the trigger input is below the VCC by 3, it will produce a high output. When the trigger is greater than VCC by 3, it will produce a low output. These two comparator outputs are connected to the next stage, which is a flip-flop. First comparator output is connected to the set pin of the flip-flop and the second comparator output is connected to the reset pin of the flip-flop. So when the first comparator produces a high output, it will set the flip-flop, so the Q will become high. Also, when the second comparator produces a high output, then it will reset the flip-flop and produce a low output. This flip-flop output is connected to the next stage, that is a power amplifier, which acts as an inverter. It will produce inverted version of the flip-flop output. That is, whenever the flip-flop output is high, it will produce low output, and when the flip-flop output is low, then it will produce a high output. This output is taken as the IC555 output at the third pin. Here we have two transistors. The first one is connected to the discharge pin, and when the flip-flop output is high, this transistor will become on, and this will allow a current flow through this transistor. That is, if a capacitor is connected across this discharge pin, then this capacitor will discharge through this transistor. And there is another pin, reset pin. Applying low voltage to this pin will force the output to low. From the above discussion, we can conclude that for having low output, threshold input must exceed the control voltage or 2 by 3, and this will make the discharge transistor is on. And for having high output, the trigger input voltage must drop below VCC by 3. This also turns the discharge transistor off. Let me stop here today. I will continue in the next lecture. Thank you.